Good afternoon. My name is Ron Singh, and I'm the sales director here at Digi International in Europe. And my presentation today is on behalf of Digi International, is regarding why Digi International modular solutions are particularly appropriate for the electric vehicle charging market and renewable energy production. Certainly, without doubt, in the last few years, we've witnessed a huge upsurge in electric vehicle proliferation, and by extension, the electric vehicle charging stations have also increased to support that market. Sorry, just adapting to the slides. Right, okay. So there are several market dynamics in play influencing the activity around EV charging stations. There's obviously been an overall increase in the number of uh, EV stations, EV vehicles being sold worldwide, and certainly there's been an increase in government activity in this field with regards to policies and subsidies being given to the smart grid industry with regards to encouraging the uptake of EVs. Certainly, from a consumer point of view, there's a huge increase global awareness around pollution and environmental impacts, and the vehicles themselves have also improved over time, particularly on the side of batteries, which has now increased to the driver vehicle range, commonly known as reducing range anxiety, i.e. the distance you need to go between needing to have a battery charge. Conversely, there are some negative impacts in factors such as lack of standardization of charging infrastructure. Even just a cable used to charge cars. I liken it very much to how the mobile phone market was about 20, 25 years ago, when pretty much every handset had its own bespoke cable. Right now, there's also what you would consider to call a primitive power grid infrastructure, even around much of Europe, where there's still quite an unfavorable mix in charging infrastructure between that which is generated by renewables and that which is still being supplied by fossil fuels. And sadly and certainly, events in the last few weeks have really highlighted that dependency on certain fossil fuels. That said, there's still plenty of opportunity for the technology to expand its adoption and revolutionize user behavior. Some of the ideas being considered right now are a way of cars giving back electricity to the grid overnight if there was any spare battery capacity, as well as the opportunity to update the existing network to more renewables, be that solar, wind, and so forth. Still a bit of a barrier to adoption is the relatively high cost of EVs versus, traditional internal combustion engine cars. And in certain geographies, there are still quite stringent rules about the rollout of EV charging stations. Domestic charging is certainly expected to be the huge growth areas. It's going to be the one that most of the users prefer, typically the domestic unit outside the front of your house. But certainly there'll also be ones being used in semi-public or public car parks, where people would leave their cars for charging, or the more sort of commercial ones required for longer trips. Certainly, though, as you can see, the expectation is that the market is going to grow somewhat seismically over the next few years. And it's interesting to see that there you go. Globally, the market is expected to grow at well over 45% in terms of the uptake of charging stations, and it's actually going to be driven largely by Europe and Asia rather than North America, which has still got much more of a gasoline-based economy with regards to cars. And just down the road, rugby, which I consider to be sort of the poster child for the EV charging market, they have probably the best selection and a range of charging stations, and really are geared up for what we'd like to see more and more service stations to look like. Just some market touch points. the market itself is sort of divided into sort of three different types of vehicle. There's the full battery electric vehicle, or just EV. There's the plug-in vehicle, plug-in electric vehicle, which is one that most people relate to, and probably the one that most people see mostly on the roads currently today is the hybrid, which is a mix of battery and internal combustion engine. But the future is definitely considered to be moving in this direction, and certainly going back to the idea of what governments are doing, certainly within the EU, there's a huge move to reduce CO2 emissions, and that to be used as a big incentive in terms of policy and money being given to support the change, helping customers to migrate away from internal combustion engines over to EVs. Just talking about the types of EV, I mentioned earlier about the sort of types of cables, which you can see in the background of the slide. In addition to that, we still need a bit of standardization around the delivery, and you can see there that currently today there's 4 standard types of power or wattage delivery for the EV charging, giving you anywhere between, requiring anywhere between half a day and 20 minutes, depending upon the current and the voltage being applied. So we still need, as I said, some maturity in standardization of cables and the delivery of the actual current, depending upon how it's being used by the consumer. So just to cover up a few things there, then again, as I said, constraints still, reasons why the public is still a little bit reticent about adopting EV. As I said, covered in the previous slide, this lack of standardization, this need for users, and I've got friends who've got cars and they have to have a couple of different adapters in the back of their car, depending upon which charging station they rock up to in a public domain. We still talk about range anxiety is still something that's in the mind of many people when they consider moving to an EV. How far will the car get before it requires charging, and what's the lifetime battery erosion over the course of the time that they use it? And then finally, just the fact that the charging infrastructure is not considered fully to be there, certainly around the more remote parts of any geography in any country. Security is also something to consider, and this was an article that was posted last year on the BBC network about the need for homeowners, particularly who've got EV charging stations outside their house, to ensure that they had all the latest updates uploaded onto the charger, because included in that was a security firmware as well, because an EV charger being connected to the house, being connected to the internet, suddenly becomes a point of entry for somebody trying to hack into the house network, or even try to hack into the provider's integration infrastructure. So if we look at sort of a breakdown of EV chargers, and I put a couple up here now. Here one is a sort of more simple one that you would expect to see outside of a domestic premises. It's quite unsophisticated. It really can't necessarily leverage the best electricity rates, or nor can it take electricity from the car and sell it back to the grid. And then on the other side of the slide, you'll see there's a much more intelligent e-charging system there, which has got much more capability to it, and that's borne out by the electronic feature set that is included on board. So I'll just look a little bit closer at that intelligent e-charger. So with an intelligent e-charger, you would expect to see obviously some sort of GUI on a display unit, normally in some way tied to the credit card payment terminal, or there could be an RFID reader. So there might be some sort of loyalty scheme or closed loop payment scheme that the provider has got to lock in customers. There'll be some sort of connectivity, whether it's Wi-Fi, could be GSM if it's a much more remote location, perhaps Bluetooth in the future, where you might be able to pay or transmit some sort of transaction data through Bluetooth. Obviously, there'll be all the charging management electronics inside. There could be environmental sensors in there. This is, after all, something that's out in all weather conditions. Could even be something like a camera, which is there to observe the license plate of the car that's rolling up and make sure it ties in with the payment process that's being used. And then overarching all of this will be some sort of very sophisticated operating system that ties all these features together, plus the necessary connectivity of sending data back to the provider and secure payment terms. If we break that down and we look at why a SOM, in this case a Digi SOM, would be absolutely suitable for the application. This particular SOM is one of our standard units, Connect Core 6 UL. As you'll see on the SOM, there is indeed an LCD interface to be able to drive a HDMI, or in other cases MIPI interfaces. There's connectivity to the payment terminals, whether it's going to use sort of an SPI UART interface, other interfaces which or equal interfaces to the RF reading mechanism. There'll be a CAN interface on board, which is very, as you're probably aware, proliferant in the automotive market. There's a secure element on board, which is the cornerstone of our security infrastructure, that keeps the whole module intact from hacking or anti-tampering. There's also wireless LAN and Bluetooth on board. There's also, in addition to the core processor, there's an additional microcontroller that can drop the whole system into a low power state until it's woken up by a transaction signal, for example. And overarching across the whole module is Digi's embedded Yocto Linux operating system, or our Android operating system as well. The ability to integrate our module, we also have single board computers, and it could be that for a very fast rollout or a low volume rollout, something perhaps for commercial vehicles, which is being done in limited numbers, the ability to just take a single board computer, which we provide, which is populated by our system on module, and use that to be the core electronics of an EV charger outside of the power management or power delivery electronics. You'll see that you also have much more of these features built in or easily accessible, in terms of having readily mounted RJ45 or USB sockets to be able to plug in your peripherals, such as your payment card terminal or an RFID reader. And that means that you could put together a system very, very quickly using a single board computer, and pretty much off the shelf blocks to build an EV charging station in a very quick matter of time. A key part of this, though, is not just the hardware, but it is the operating system. Digi, as a very prominent supplier of modules, of system on modules, has a very comprehensive embedded Yocto Linux platform. We take, for example, you can look at this one here, just the basics which are provided by a silicon provider, and we build a lot of our own IP around it, including, and I mentioned it already, the security system. We have what's called Digi Trust Fence, which is our security platform, and includes everything from secure boot to anti-tamper, to make the system as secure as possible. And for an application like this, where you are talking about delivery of power, transactions through payment, either not directly with a credit card, but say through an RFID or some other method of identification, having a system that is tamper resistant is extremely important and extremely valuable to the end user, but also the people who might be owning the equipment or rolling out or leasing it out, either commercially or domestically. In addition to using a system on module, for some more sort of computer-based charging stations, we also offer a range of RF-based modules for connectivity. We offer a range of modules being used in sub-gigahertz for long range, or 2.4 gig for short range, or even cellular, GSM-based for extremely long range. And these are often complemented by some kind of gateway. You'll see one of our gateways at the bottom there that allow RFID modules being laid out in any particular topology, for example, mesh, being able to be aggregated to a gateway and then transmitted out to a central data system somewhere else. And this very same technology that we employ in these sort of charging stations, we also employ at the power generating side. I mentioned earlier that there is a need to take what is by all accounts a very primitive power delivery system that we have today, a mix of renewables and still quite a reliance on oil and gas and coal, and get more online with solar power and with wind and so forth. Digi is very much at the forefront of providing modular solutions for the solar panel farm market, and we provide a family of modules that are very suitable for use in the tracking system of moving the panels around to match where the sun is going. So I've talked a lot about why our solutions are so appropriate for this market, and there will be many people who go, well, why can't we just go chip down? As I mentioned right at the beginning of the presentation, this market's time is now. As said, unfortunately exacerbated by some of the things that are happening today in the world. But certainly the awareness of making the environment a priority in terms of reducing pollution, either CO2 or just digging up the earth to get more materials out. And then the fact that there is this move by government to get more and more of the consumers to move away from internal combustion engines towards EV means all the investment is being made right now. The rollouts are happening now. That example I showed you of the rugby moto services, that's where we want to see all of the services in the next 5 years. In order to do that, it means the companies, whether it's the utility companies or the energy companies or third-party companies, need to be bringing their solutions to market today. Today is the sweet spot to be bringing out really good EV chargers for all tiers of the market, domestic, commercial, and industrial. That means doing this on a chip-down solution is a miss. It's going to take anybody at least 2 years to get down and do a chip down solution and then bring it to market. And by then they probably would have missed the best opportunity. And that's what this slide here is about. This is really what we call our build versus buy argument, and it's particularly appropriate to this market. In build versus buy, we talk about some of these things here like opportunity cost, and that means not having your engineering resource focused on redesigning or designing a PCB when they should be focused on productionizing a product. Timing advantage, again, very appropriate to this market. If you can get your product out now at a higher ASP, then you buy a march over your competitors who are probably following behind you. It's a very simple piece of paper exercise to work out just how much money you can generate by going with the timing advantage of getting your product to market early. Technology debt we talk about is when you build a product, you own it. And so if you build a product from a chip level, you own it for the lifetime of its place in the market. If there are spares required, if it needs redesigning, if redesigning then requires recertification or reapproval, you own the cost of all of that. With a modular solution, you offload a good portion of that onto your module provider. Going back to the timing advantage, I also equate that with on-time NPI. Chip down solutions invariably run over budget in terms of time and often on cost. I've never seen a chip down design turn up on time. Certainly with a modular solution, you stand more chance of an on-time new product intro because there won't be so many board respins and so much debugging because a lot of the work has been done for you by the module provider. I'm now actually having problems seeing the last part of my slide there, so I'm going to skip that because I can't read it. Apologies for that. So again, just looking at the core competencies required for chip down, you certainly need to be able to do all your own hardware design. You need to be able to do your component selection, make sure that your components can coexist well together, your board design, making allowances for RF and other issues to be considered when you're designing a PCB from the ground up. Likewise on the software, if you're going for a bare bone designs and you're taking software being provided to you by each individual chip supplier, then you are going to have to do the job of integrating all the drivers and other piece of code to get your system operational before you put your application layer on top. If you go with a good module supplier, then they'll be giving you quite a comprehensive board support package with operating system and all the drivers provided, and it's all been tested, it all works. You can get to simultaneous hardware and software development very, very easily. If you go with your own PCB, you've got to think about manufacturing. And right now, in these current conditions, that's a real problem. As you're probably aware, there's a global chip shortage, and this is impacting the ability of customers to be able to build their product. If you are building with a SOM, or system or module, then you're ordering one part number, and I'll come on to that shortly. About that. So all of that together wraps up into your impacting your time to market and your opportunity cost. If you can reduce those three, you can get to market quicker, you can make an impact on the market, win more customers, be in production and be shipping units quicker. Going back to that issue of components count and the manufacturing side of thing, which is really, really important at this point in time with the global chip shortage, which has been going for just about a year now, and it's anticipated will go for another year. When you look at a system or module and you talk about ordering one part, you are having to just consider one part to be bought for your carrier board. If you choose to go with a chip down solution, you've got to make sure that you've got full access of supply on your processor. The same thing with all the other key components that can't easily be replaced, such as a security element or an administrator MCU or the radios. You might be a little bit lucky or memories, but again, you may be designing your board so it's available for the next 7 years, which is your burden of technology debt. So you may be securing slightly niche memories in the knowledge, or in the hope rather, that you can secure them later on down the line. And then on top of that, you have all the other ancillary components, the PMIC, power components and so forth, signal chain. And when you look at, say, a very simple, by all accounts, simple SOM based on an IMX6UL, there's something like 200 plus components on that. And if you look at a much more complex one based on something like an IMX8X, you're looking at over 400 components. Again, that impacts your ability to get your product to market quickly. If just a handful of those components in your bill of materials are hard to get hold of, or you're paying 10 times PPV to get hold of them in the quantity you need, you hold up your production or you delay it significantly. If you're getting a SOM from one supplier, you've only got to worry about the supply of that one product. Again, just talking about time to market, um, just looking at the base design for how you arrange your processor and the key components around it. You've got a lot of aspects, and this list is by no means, this list here is by no means exhaustive, but certainly it covers some of the things that you need to think about when you're doing the original hardware definition and also the software work that goes alongside. Equally well, you have to think about the same sort of aspects when you start considering the rest of the carrier board and how that's going to be manufactured for you. As I said, right now in these current times, that's a real issue. There is a perception, or by all accounts, a misperception that SOMs lock you in and there's no way to scale with that. Actually, that's not true. A good SOM strategy would allow you to scale in either direction. A good SOM strategy would allow you to bring out a product very, very quickly. Let's say you had to put together some prototypes or some pre-production modules, you could some pre-production units. You could do that very quickly with a system, a single board computer based on a system on module. You get your first units out based on that single board computer, proof of concept, first few production units to show your customer that you got something that works. As you then move to the next volume step, a company like Digi will give you all the Gerbers and schematics and the bill of material for the single board computer so that you can pare it down and build your own carrier board and populate it with our system on module. And then should you decide that you are reaching the heady height volumes that you aspire to, that you want to go chip down, then you know that you're able to use the same sort of gold partners that Digi uses, such as, say, ByteSnap, and they would be able to help you facilitate going to a chip down solution if you felt that that was an economic, good use of your time to do that. I put some numbers in here, but I just wanted to kind of show some scalability and just some of the risk impacts between going with a single board computer, a SOM, and going chip down. Obviously, looking at the production, the BSP side of things, if you buy an SPC or you go with a SOM, you have a production ready board support package. If you go chip down, you're going to get the chip down, the chip vendor's board support package, but then you still need to think about all the other components and make sure you integrate all the drivers and so forth. Obviously, if you use a single board computer, there is no PCB to design. You just go ahead with that. If you use a SOM, then a good supplier like Digi will give you all the details of our single board computer so that you can quickly, easily adapt it to your own carrier board, knowing that you have used proven technology that coexists well together. Obviously, with a chip down solution, you get a carrier board for that chip, but then you have to pretty much start from scratch to build your PCB. So you can see there basically the difference in developmental costs as you go from single board computer to SOM or to a chip down solution. And those costs can't be ignored. It's not just about the material cost. It's about your engineering resources, time, and how quickly you get to market or miss the opportunity to sell your product. I put some volume numbers in there, but honestly, they're really misguiding in as much as we have customers who are buying modules in hundreds of thousands of units per year because it makes commercial sense for them to do so, given all the things I've talked about previously. Here's another example, again, We talked about the requirement of more remote EV charging stations to have a GSM-based technology rather than wireless LAN or any other. And Digi, we provide gateways. So if you had a range of or a set of remote charging stations, you could connect them all together using our RF modules and have that data aggregated to a cellular gateway, and then the data would go off to wherever it was being harvested and stored. Equally well, though, we also do in what we call embedded modems, or RF modules with GSM technology based on board. And again, we do offer from that the ability for someone to scale to then module based, such as the U-Blocks modules, which we use in some of our modems, or then onto chips, because all of our technology is largely based on Qualcomm cellular technology. I talked about the software there, really important part, and something that's often underrepresented when those commercial conversations are happening, but highly valued by engineers. A good module board support package, as I mentioned, very comprehensive in terms of having all the drivers, all of the necessary libraries to support applications, and most importantly, it's been validated. And by giving your software team a single board computer with the BSP, while the hardware team is adapting a single board computer to make an optimized carrier board, you can have the hardware team and software team working in parallel and performance testing as they go along. Again, another way of reducing your time to market. Looking at the wireless side of things, if you go chip down, you have to think about approvals. Obviously, around the world, there are various government, national approvals or certifications that have to be acquired before you can release a product onto the market that is transmitting and receiving on those bands. Each time you do that, there is a cost attached to it. If you go with a chip down solution, every time you change a chip or every time you produce a board with that chip, that board has to be approved, has to go through the necessary approvals or certs. If you go with a modular solution, then that module is at least partially, if not fully approved, and you've removed some of the work for yourself on that. And these are not cheap things to do. If you think that you do them if you have a range of products, you have to do this for every product. So the more that you can amortize that across your volume by offloading that onto a module provider, and in these times where, again, going back to the component shortage, components are having to be changed all the time. We at Digi, we've seen certain radios come and go, and we've had to adapt that. Every time we make a change of a radio component in the module, it's invisible to our customers. We make that change, we carry the cost burden of redesigning, we carry the cost burden of reapproving, and we sell the module to our customer, and they carry on and get on with their finished product. So just a couple slides because I'm aware of the time. Just another thing to think about with regards with going with the modular solution. Modules are upgraded all the time. The core processors are changed, the memories can be adapted, the radios might be changed to accommodate new bands in Wi-Fi, for example. Certainly, using a modular solution, a good module provider will give you a roadmap of upgradability so that you always know over the years that there's a path of migration that you can easily adapt to. Equally well in a modular solution, there's also some kind of flexibility built in. So there could be a choice between going with Wi-Fi, Bluetooth, or going Ethernet only, having extra memory on board, be it the RAM, be it the flash, which is then just a simple part number change, and the footprint should largely remain the same. Again, just another aspect to think about if you're going down with your chip design, you have to think about the economies of scale. Are you getting any? If you are buying your components yourselves in your own volumes, how does that stack up versus the price you are getting from a module vendor who's buying components in hundreds of thousands, if not more, because that's all they do. They just make modules. So are you really seeing the economies of scale that are available to you in the component cost you're being offered versus buying a module. Again, if you can then have got a range of products that you are making and you're able to use the same module or the same module family across all of your products, it's a way, again, a way of consolidating your demand. And if you do go chip down, there's a lot of design equipment, hardware design equipment, particularly if it's RF enabled, that you'll be using to do that design. And it's also your responsibility to maintain them, make sure they're regularly calibrated and so forth, because that's all part of your technology debt, that burden you have of maintaining the product for its lifetime. IoT, I talked about this earlier when I mentioned about the security updates for the EV charger, the bulletin that was done by the BBC, not exclusively, last year. It's just something to think about with IoT in general. Anything that's hanging off the internet becomes a security risk in itself, i.e., your data being taken and given to someone else, or a gateway being used to infiltrate an energy provider, or because that charger is outside your door hanging off your network, it's a way to hack into your house. Could be your home security system, could be your entertainment system, however, you've got your own storage. So thinking about a solution that a customer would want to buy in terms of an EV charger means being able to assure that customer that you've got good security around your system. And as I mentioned, Digi is very proud and very pleased to be offering the Trust Fence security infrastructure that we offer with all of our products. So then, wrapping up now, just a reminder who we are. Digi is a 30-plus-year-old module vendor from the US. We offer a range of modules, both system on module, which is an embedded processor together with memories and connectivity, be it hardwired through Ethernet or Wi-Fi, Bluetooth. And we offer very robust and well-proven operating systems supporting Android, Linux, and actually in some instances on some of our older products with Windows CE. The other half of our business is XP. XP is our brand of RF modules. We have a whole family of modules which support different types of mounting, whether it's through-hole, surface mount, micro surface mount. We support a range of topologies, mesh, what have you, and we support a range of frequency bands, sub-gigahertz, 2.4 gigahertz, cellular, and then within those bands we support a range of protocols such as Zigbee, 802.15.4, our own proprietary DigiMesh. The beauty of the XP modules is whichever one you pick, the footprint is identical, so you can swap out and move between frequency bands or technologies or topology support without having to adapt your PCB to take that module. Just looking at DigiConnect Core, as I said earlier though, DigiConnect Core is not just about the module, it's this whole infrastructure we build around it. It's the board support package, it's all of the software development tools like Smart IO Mux, which speed up your design, its connectivity, Wi-Fi, Bluetooth, its integration to cloud providers like Azure and AWS that builds a whole ecosystem around our offering. Anybody could make a highly integrated PCB. We happen to think we do it the best, but it's everything else around it that counts and is our differentiator. We offer a range of products. We do SOMs, we do single board computers, and we assist in movement between one and the other. And I'm going to just speed up now because I'm aware of the time. I want to just get to the RF ones. And then same thing with the RF XP modules. I've already showed you this. We do different form factors, but the pinout is always the same. We do all the software tools around it. And it's more than just selling the module. It's about the entire infrastructure, the software tools, the connectivity, the integration with cloud providers that makes Digi a significant supplier in this market. I think I've just about made it to my last minute of this, so thank you very much. If you want to get hold of this presentation, I know it will be made available either by the organisers or by our distributor, Solid State Supplies, who very kindly invited me to do this presentation. So thanks to them, and thank you for making your time available to spend.